Hey everyone, so this is lesson 3-2 in Algebra 1. So today we're going to be talking about how to solve systems of equations using substitution. So our goal is to just understand how to do this. This is what's called an algebraic solution. It's not a graphing solution, so we just solve it using algebra. So we call that solving it algebraically. And overall our goal for any sort of system of equations is to understand what is the solution, and then how do I tell how many solutions there are, right? Because we could have a situation where there's absolutely no solution, right? We could have a system of equation that has only one solution. We could also have a system of equation that has infinite number of solutions. So one of the things we're going to be talking about is how to determine that, and what does that look like when I'm just working algebraically. We kind of know what that looks like visually, graphically. So if we look on a graph, right, I can tell where two equations, where two lines cross, right? That's my solution. And if they just cross, I know that it only has one solution. If two lines are parallel, right, two lines are parallel, they never cross, that means I have no solutions. And if two lines are sitting on top of each other, right, they occupy the same space, we say that they have an infinite number of solutions. Graphically it's easy to tell, but what does that look like algebraically? So as we're just working on solving problems, what does that look like when we run into one of those special cases? So that's what we're going to look at today, in addition to looking at some methods for solving a system algebraically. Alright, so one thing to keep in mind, and this kind of gets to the heart of solving for systems of equations, especially algebraically. If we think about a problem where we have two variables, right? We have an equation that has two variables, and we want to know what the value of those two variables is, right? We want to know what those variables are, the values of them. We can't do it with just a single equation. It's not enough information to actually go and solve that. I can say, well, if the x variable was equal to this, then I could figure out what the y variable was. Or I could say, if I knew what the y variable was, I could figure out what the x variable was. But just having an equation, I can't tell what both of those are at the same time. So the example I show here is x plus y equals 4. Well, I can think of lots of examples where I have two numbers that would add up to 4, especially if I think of positive numbers and negative numbers, if I think about fractions and decimals. There's really an infinite number of pairs of numbers, right, that will add up to 4. So this equation isn't enough to tell me, what is the value of x and y in this particular situation. It tells us kind of a general case. If we want to get to a very specific case, we have to have more information, or more what are called constraints. So we talk about constraints. Constraints are just, these are the things that has to happen in order for this situation to work. So in this case, if we have just x plus y equals 4, that's not enough information. But if we said x plus y equals 4, and we put another constraint on there that said that maybe x minus y equals like -3. Okay. Well, now I can come up with a very specific set of numbers. I can say, well, there are only two numbers that add up to 4 and that have a difference of 3. And I can look and see how to do that algebraically. So what they talk about here is the number of variables. So if I need to find a solution for all the variables, that the general case is that if I have more than one variable, I have to have more than one equation. So for example, if I have two variables, I have to have two equations in order to solve that. If I had three variables, I would need three equations or three constraints to help me solve that and find the value of each one of those. So the number of variables and the number of equations have to be the same in order to come up with a unique solution to that. So that's generally what we're going to look at. The way that we're going to do this is we're going to try to somehow combine these equations, right? We're going to combine the two equations, and we're going to do it in such a way that one of the variables disappears. And so there's a couple of methods we're going to talk about. We'll talk about the substitution method, we'll talk about the elimination or the addition method, and both of those ways are just kind of tricks that you can do to combine two equations into one equation and get that one equation down to one variable. And that's really our goal. Once we can get one variable, one equation, then we can solve for that variable. So here's generally how we're going to do this process. And the number of steps that you have to go through and which process you choose is going to depend on, you know, the equations that you start with. But for the substitution process, right, for the substitution method, the first thing we want to do is we want to make sure that we get one variable all by itself. Okay, so in one of the equations, we want to get one variable all by itself. Now, if I look at this, set of equations here, I've got two variables, right? I've got two equations and two variables. I should be able to solve this if there's a solution. I know that y is equal to 2x plus 5, and I also know that y is equal to negative x minus 4. So I have two constraints on here, right, or two equations. And what I want to do is I want to try to combine these so that I get rid of one of the variables. Okay? And the way that I do that is first I get one of the variables by itself. So in this case I've got y by itself here. And I've actually got it on two equations. I've got it on this top equation, I've got it on this bottom equation. So I only need it for one of them, but in this case I have it for both of them. So what I'm going to do here is I'm just going to do substitution. And what that means is I'm going to replace y in the second equation with whatever it says that y is equal to. So in this first equation it says y is equal to 2x plus 5. So I'm going to replace y with 2x plus 5 in the second equation. So if I do that, I get y, so I'm going to replace that with 2x plus 5 is equal to this, negative x minus 4. So here I've rewritten that second equation, right? And instead of writing y, I substituted the first equation into that. Alright, that's why it's called the substitution method. I'm taking one equation and I'm substituting it into the other equation, or I'm replacing part of the second equation with the first equation. Okay. So now I have this equation. Notice that there are no y's in here anymore, and that's our goal. That's what we're trying to do. And so we can go ahead and just solve this. Like, we know how to solve this, right? We're just going to get all the variables on one side, we're going to get all the constants on the other side, and we're going to divide by our leading coefficient. And so to do this, I'm going to get all the x's together. So I'm going to add x to both sides. I want to get rid of the x on the right hand side, so I have a negative x, so I'm going to add a positive x. And so on the left hand side I get 3x plus 5, and on the right side I just have negative 4. And then I want to get the variable term all by itself. So I have a plus 5 here, I want to get rid of that, so I'm going to subtract 5 from both sides. And so now I have 3x is equal to negative 9 when I combine those together. And now I just need to get my x by itself, right? So I don't want 3x's, I only want 1, so I'm going to undo this multiplication with division and divide both sides by 3, and so I get x is equal to negative 3. Okay, so now I know what the x value is. Alright. Now, I still need to figure out what the y value is. I've only got one variable so far that I've solved for, and I need to solve for both of them. So what do? Well, I know that x has to be negative 3. So I can just take negative 3 now and put it into either one of these two equations. Okay? So to find out x, I'm just going to put negative 3, and I'm going to put it into the first one. And so I'll use a different color here. So I'm going to use this value, x equals negative 3, and I'm going to substitute it into the first equation. So I got y is equal to 2 times x, but I know that x is negative 3, plus 5. And so I know that y is equal to negative 6 plus 5, and so I know that y is equal to negative 1. So I know here that x is negative 3, and I know that y is equal to negative 1. Okay. Now, if I were to graph these two equations, right, if I were to graph y equals 2x plus 5 and y equals negative x minus 4, I should see that they cross at the value 3, negative 3, negative 1. Negative 3, negative 1. And I'm going to leave that for you guys to verify. You can go out to Desmos, type in these two equations, and see that they cross at -3, -1. So this gives us a way of solving this algebraically, right? Algebraically, without having to graph it or do any, sort of thing like that. We can just look at the math and do it just like that. Okay. So here's our steps here again. We're going to solve one equation for one variable. In this case, we already have it, and we're going to take and substitute one equation in for the variable in the second equation. Okay, that's why it's called the substitution method. We took the 2x plus 5 and we replaced y in the second equation with 2x plus 5 from the first equation. And then once we figure out what that one variable is, we can go back and then plug that into one of the equations and figure out what our other variable is. Okay, so it's a little bit of a process there, but that's generally the steps that you're going to go through. Let's look at another example. So here I've got two equations here. Okay. Notice that these equations aren't as nice and lovely as the last example, but the process we're going to go through is the same. We're trying to combine these two equations so that one of the variables goes away. So our first step is we're going to solve one equation for one variable. And I can choose whichever variable I want in whatever equation I want. I'm going to make it easy on myself. I've got this x right here that's all by itself, right? There's no number in front of it. All I have to do is move this 5y to the other side and I'll have x all by itself. And so that's what I'm going to do. I'm going to rewrite this equation here. I'm going to add 5y to both sides. And so this is going to tell me that x is equal to 5y minus 7. Okay, and that's the situation I'm looking for in order to do this substitution process. I've got x all by itself, and I know that x is the same as 5y minus 7. So what am I going to do? Well, I'm going to take 5y minus 7, and I'm going to replace x with that in the other equation. So in this case, I'm going to have 8, but instead of x, I'm going to substitute 5y minus 7. Plus 8y. So I'm just rewriting that second equation, substituting that value in, equals -8. Okay, so here's 8. This represents x plus 8y is equal to -8. So now I've got one equation, I've got one variable. I should be able to figure out what y is. So in order to do this, I'm just going to go ahead and distribute and solve this. So we should be pretty good at this this part of it by now. So if I distribute this, 8 times 5 is 40, so I've got 40y. And if I do 8 times 7 is 56, so I've got -56 or minus 56 plus 8y is equal to -8. If I combine my like terms here, I've got 48y minus 56 is equal to -8. I want to get the y term all by itself, so I'm going to add 56 to both sides. And so I get 48y is equal to 56 minus 8 is 48. So that actually works out nicely. And if I divide both sides by 48, I would see that y has to be equal to 1. Okay. So now I know that y has to be equal to 1. I can go back and figure out what x is. Well, I've already got this equation here that tells me how to find x. So I can just substitute that back in. I can say, well, if x is 5y minus 1, then x has to be 5 times 1, right? 5 times my y value, minus 7. And so I get x is 5 minus 7, so I know that x has to be -2. So what's my solution? My solution is when x is -2 and y is 1, or I could say it's at the coordinate -2, 1. Okay. And again, you could verify that graphically. You could go to Desmos or a graphing calculator, put those two equations in and see where they cross, and they should cross at the coordinate -2, 1. Okay. And in general, that's the substitution process. Sometimes you have to work a little bit in order to get that variable all by itself, but just pick whatever variable you want and get it all by itself. If you were kind of clever about this, you could see that, well, maybe, look, these are all multiples of 8, right? This is 8, 8, 8. I could divide everything by 8 maybe and turn those all into 1s, and like that might be another way of solving it. There's an infinite number of ways of kind of manipulating and working these problems, but your goal is to pick the one that makes the most sense to you and that gets that variable all by itself in a way that makes sense to you. Okay, here we have one more example here. This one, again, the equations are not in an easy format, right? They're not in an easy to see sort of thing there. I don't have a variable that's all by itself, right? I don't have that. I could get that, right? And there's a number of ways that I can do that. But it looks like whatever I do, right, I'm going to end up with a fraction. If I divide everything here by 2 to get my x by itself, I'm going to get a fraction here. If I divide everything by -3 to get my y value by itself, I'm going to have a fraction here. If I divide everything by 6, I'll get a fraction. If I divide everything by 4, I'll get a fraction. And that's just the way it works out sometimes. So we're going to go ahead and solve this using substitution, and we'll just pick one that, just one that we like. And I'm going to go ahead and solve for x, and I'm going to use this first equation. Okay, it doesn't matter which one, but this is just my personal choice. So I'm going to rewrite this, and I'm going to add 3y to both sides. So if I just add 3y to both sides up here, okay, so I get 2x is equal to 3y minus 6, and I'm going to go ahead and divide by 2. I'm going to divide everything by 2, and so I get x is equal to 3/2 y minus 3. Okay, so now I've got x all by itself. I can use this to substitute into the other equation, and so that's what I'm going to do next. I'm going to take this x is 3/2 y minus 3, and I'm going to replace x in the second equation. So I'm going to have 6y is equal to 4 times my x, and my x here is 3/2 y minus 3. And then I've also got minus 12 on the end here. Okay, so there's my substitution step. Yeah, I've substituted the second equation for x in the first equation, and so I can go ahead and solve this. So now I've got 6y is equal to, so if I multiply this, 4 times 3 is 12, and 12 divided by 2 is 6, so this is going to be 6y. And then I've got 4 times -3, that's -12. And then I've also got this -12 out here as well. Okay, so I'm getting close, right? So now I can combine my like terms here. So on the left side, I've just got 6y. That's a 6. It's poorly drawn 6 equals 6y minus 24. And for some reason, boy, my screen here just does a horrible job as I start getting deeper into these problems. But I'm going to come up here and see if that helps at all if I write kind of on the top of the screen here. So now I'm going to subtract 6y from both sides. So if I subtract 6y from both sides, so what I end up with is, and again that looks horrible, but this is 6y minus 6y, so that's 0. Okay, so I've got a situation here now where I don't have any y's left. So I've got 0 equals -24. Okay, And this is one of those situations, right? I've come to this point in the algebra where like things have just kind of stopped making sense, right? This tells me that in order for this system of equations to have a solution, that 0 has to be equal to negative 24. And we know that it doesn't. Okay, so 0 will never equal 24. So what that tells me is that there is no solution to this system of equations, right? I worked through the problem algebraically. I can go back and check my steps and make sure I didn't make any mistakes. But when I get to a situation like this, right, where the math just kind of quits making sense, then I know that this is a no solution. That's just such horrible writing here. But let's try this again. This is no solution. Okay, so that's what that represents, no solution. That tells me that this is only true when 0 is equal to negative 24. That never happens, so there can never be a solution to this. If I were to graph these two lines, right? If I were to graph these two lines, I should see that the lines are actually parallel to each other. Okay, that the lines are parallel to each other and they will never cross. That's why there's no solution. So that's what that looks like when we solve that algebraically. We just get to a point where the variables disappear and we're left with an untrue statement. Okay, 0 does not equal negative 24, so therefore there can be no solution to this. Okay, we'll talk about the elimination method tomorrow. So I'm going to go ahead and end the video here. There is one other situation, I guess I would say, if you're working through a problem and you get a similar situation, all the variables disappear, right? All the variables go away, and you're left with a true statement. You're left with something like 0 equals 0, or 5 equals 5, or negative 2 equals negative 2, right? Where all the variables disappear, and it's a true statement. Then we would say that that is an infinite number of solutions. Okay, that means that is always going to be true, and there's an infinite number of solutions there. So that's kind of how we would look at those two situations. But okay, so I've also posted a video by a lady named Nancy Pye. It's a YouTube video. She kind of walks through this as well, and so she'll kind of walk you through some of those different situations. It's a good video. I highly recommend it. I think she does a good job of explaining it, probably a better job than I do. But I'm going to go ahead and end the video here, and you can take a look at the homework problems and let me know if you have any questions.